So in the last video I said you could use T results for a few things. One is to do a proof. The other one is to work out values of angles, all right? And the third thing is to use it to solve equations. Equations that you cannot solve using any other method apart from this T method, or next lesson you are going to learn about the auxiliary angle method. Now, so this exercise 617, further trig equations. We use T formulas to solve equations of the type. Now you haven't solved equations like this. A sine theta plus B cos theta equals C, where A, B and C are constants. Now you are only used to solving something like A sine B plus B cos, A sine theta plus B cos theta equals 0, like this. Notice that we can solve the following type of equation using ordinary methods. You've solved ones like this before. When you've only got sine and cos and a 0 there, you can divide by cos to turn it into a tan equation. So you can either divide, so here we can either take the 4 cos theta over and then divide, or we can just divide, so we can do that first. 3 sine theta plus 4 cos theta is 0, so 3 sine theta equals negative 4 cos theta. Whenever you have an equation with only sine and cos in it, no squares, you always divide through by cos theta, because it doesn't eliminate an answer. It just, because sine on cos is tan, and whenever you've got tan, you have sine divided by cos. Couldn't I just move this cos theta underneath, rearrange? It's the same thing. So if you know how we can rearrange and make denominators here if we want, I can put the cos theta under there. And I get sine theta on cos theta is tan theta, and I can put this 3 down there. All right? So what we're going to do is solve this equation. So I'm going to divide through by cos theta. All right? So let me do that. So I've got 3 sine theta over cos theta equals negative 4 cos theta over cos theta. Actually, you know what would be even better to divide by? What would you like to see here? 3. That's all right. Let's just divide by 3. Divide by cos. So what do we get? 3 tan theta equals what? Negative 4. Now you can move the 3. Okay. So whenever you see something sine theta plus something cos theta is 0, or you see it in this format, sine theta equals cos theta. Sometimes they don't have numbers in front, sometimes they do. That's solvable by dividing by cos theta, because sine divided by cos is tan. You don't lose solutions. Wait, to do this, I want you to solve for quadrants from 0 to 360. Before we start, we follow the 3 steps as we did in 2 unit. Which quadrants? Quadrants, tan is negative in quadrants 2 and 4. Acute angle theta, you do not put the negative into your calculator. The negative only tells you the quadrants. So we want shift tan of 4 on 3, which is 53 degrees and 8 minutes. So we want quadrants 2 and 4. So therefore theta, I'll just put roughly a 53 there and a 53 here. So what's theta? 180 minus 53 degrees 8 minutes and 360 minus 53 degrees and 8 minutes. And are we okay with that? 180 minus 360 minus for quadrant 4, going this way. What have we got? Okay, 126 degrees 52 minutes and 306 degrees 52 minutes. Now, we have done ones like this a few weeks, like last week or something, right? But these are fine. But I need to show you this because I'm going to show you something different now. And this different one, we use either auxiliary angle method or T formula. And because we're doing T formula today, I thought we'd look at T formula. So, however, to solve trig equations of the type A sine theta plus B cos theta equals C, notice it's not equal to 0 anymore. where A, B, and C are constants, you can use one method is to use t results. That's your first method. Tomorrow we're going to learn a different method. So we just replace cos theta and sine theta with their t results. But remember the definition, t equals tan theta on 2. So let's solve this. 5 cos theta minus 12 sine theta. Actually, I don't need to rewrite that. All right, let's replace 5 times. What's the result for cos theta? 1 minus t squared over 1 plus t squared minus, I might just go bracket, all right, 12 times. What's the t result for sine? 2t over 1 plus t squared equals -3. You must define what t is, where t equals what? Tan theta on 2. Okay. So I've got on my numerator 5 bracket 1 minus t squared minus 12 times 2t. Haven't I just got one denominator? 1 plus t squared equals -3. Are we okay with that? So I've got 5 times that t result minus 12 times that t result equals -3. Now I'm going to solve. I need to expand the numerator, multiply across there. So I've got 5 minus 5t squared minus 24t equals -3 times 1 plus t squared. I've cross-multiplied. So what have I got here? 5 minus 5t squared minus 24t equals -3 minus 3t squared. Let's take everything over to the right. So we just take everything over to the right. Minus 3t squared plus 5t squared is 2t squared plus 24t. Minus 3 minus 5 is minus 8 equals 0. Is everyone getting in the same? What should I do just to make things a bit simpler? Yeah, divide by 2. I get t squared plus 12t minus 4 equals 0. Now I can't solve that. There are no factors of 4 that add up to 12, whether it be -4, +4 or anything. You have to use the quadratic formula. All right, so t squared plus 12t minus 4. So do the quadratic formula with that. I've got t equals -12 plus or minus the square root of 144 minus 4 times 1 times -4 over 2 times 1. So t is -12 plus or minus the square root of 144 plus 16. Is that 160? Over 2. T is -12 plus or minus square root of 160. 16 times 10. 4 root 10 over 2. And dividing everything by 2, it's -6 plus or minus 2 root 10. Okay, that's what tan theta on 2 is. Remember the definition for t is tan theta on 2. Now, solve this for 0 to 360. I've got an equation, tan theta on 2 is that. I need to change my domain. My domain is for solving between 0 and 360 for theta. I have to go between 0 and what? 180 for theta on 2. Okay? So I've got to take 2 pathways here. Tan theta on 2 is either -6 plus 2 root 10 or tan theta on 2 equals -6 minus, sorry, I'm running out of room, minus root 10. So remember my domain is from 0 to 180 for the angles of theta on 2. In other words, you don't have to do 4 quadrants. When you're working in theta on 2, you just have to do quadrants 1 and 2. Please, that's really important. Okay? Otherwise, when you're finished, all your results are going to be bigger. Now, I'm not sure if we did theta on 2's. Remember we did 2 thetas and all that sort of stuff? So what we have to do you think this is positive or negative? See, I can't tell either. Well, root 10's a bit bigger than 3, isn't it? That's a bit bigger than 6. That's positive. But if you're not sure, you put it in on your calculator. This is negative. No, it's not. It's positive. Isn't it positive? Just work out what negative 6 plus 2 root 10 is. It should be positive. That's positive. You know why I'm doing that? 10 something is positive. What's that tell me? The quadrants. What quadrant is this? Good. I don't have to do quadrant 3 because we're only going up to 180. This one's definitely negative. This one's negative. This is my quadrant 2 result. So I don't have to bother about doing anything apart from quadrant 1 here. I don't have to bother about doing anything apart from quadrant 2 for this one. But, okay, so that means that, you know, if you can work out what this is as a decimal and go shift tan and it'll give you the theta on 2. Does that make sense? If tan of something is that, if it was a decimal, don't you do the angle is shift tan of that? But I'm getting theta on 2. This is my acute angle theta on 2. Is shift tan of that whole thing. And is that, be careful, I need degrees, minutes, seconds. 17 degrees. Now, the reason you do not round this is that's theta on 2, and I have to solve from 0 to 360. Do not cancel that answer. Multiply it. I need theta, not theta on 2. The question says solve for theta, not theta on 2. Look at the question. You solve for theta. So that's theta on 2. Do not cancel it. Multiply it by 2. Because what will happen is sometimes you'll get a mistake with the rounding if you round it here. So what do you got? 35 and which is 35 degrees 58 minutes. That's what theta is there for that quadrant 1 answer. That's okay. Now I'm just going to write down what the equation is over here. I've got 5 cos theta minus 12 sine theta is negative 3. If you wanted to check that this is okay, you just go 5 times the cos of 35 degrees 58 minutes, roughly, that'll do, minus 12 times the sine of that angle, and hope you get something very close to negative 3. You know it's the answer. So when we substituted that into the original equation, it was negative 3. Let's look at our quadrant 2 result. Remember the negative, what I would do here actually, and I think you can do it, is just do shift tan of that whole thing and it will spit out the quadrant. I don't know, may not spit out the quadrant 2 result. It'll probably spit out the quadrant 4 result. See what you get. Just do shift tan of that negative thing. Just do it and see what you get. So I'm going to do shift tan of the negative result, negative 6 minus root 2. You get negative, what'd you get? 82. So this is not good. That's not a quadrant 2 result. So you can't put the negative in. So what you need to do with this is, what you do here is, this is what I would do. Tan theta on 2, get a decimal value for that, for the negative 6 minus 2 root 10. So go negative 6 minus 2 root 10 is negative 12.324 whatever. But you know when you have to do the angle, you don't put the negative in. Do you remember? The negative tells you the quadrant. So just times that answer by negative 1 on your calculator to make it positive and do shift tan of that, answer, and you will get 85 degrees. This is the acute angle. 85 degrees, 21 minutes, 40.5 seconds. Sorry, calculator sitting there. Do you understand what I've done? The negative just tells me the quadrant. When I do shift tan, I'm not supposed to put the negative in. If I do, I end up with negative 85, but you'll just have to pull the negative off that if you don't want to just put the positive thing in. It'll give you the quadrant 4 answer. I need the acute angle, which is 85 degrees. Remember, it's quadrant 2, so theta on 2 is 180 minus 85 degrees, 21 minutes. Actually, I don't, yeah, just keep it all there, 40.5 seconds. I need you to keep it there because I've got to multiply that number by 2 in a minute. Okay, and what do you get? 180. So remember, acute angle that, and then we do 180 minus that to get my quadrant 2 answer. Don't double it yet and then add the 180. That's what I'm trying to say. So what have you got for that? So with that answer, just if you want, subtract 180 and you'll get it as a negative, but write it as a positive. I've missed it. Anyone got it? So that's theta on 2, therefore theta is the double of that. So just times that by 2. So you don't want to be deleting any of these results. So 17 minutes. Now, to check that that's right, put that answer, 189 degrees, 17 minutes, into this equation, and hopefully you get something very close to negative 3. So we need to do one more thing. We must test for 180 degrees, whether theta is 180 degrees. We must test, so always for the T formulas only, you must test whether theta equals 180 degrees is a solution. And look, sometimes it will be, but I tell you when it will be. See how here I've got a quadratic formula? If when I come to get that quadratic formula that I end up with a linear equation, then T will, 180 degrees will be. So coming back here, if my T squareds cancel and I don't have T squareds here, theta is 180 will be a solution. All right. So we just have to test in this equation above whether theta is 180's solution. You know how you got these 2 results and we just quickly checked them and they worked? We did. We put 35 degrees, 58 minutes in there and we got negative 3. And we put 189 degrees, 17 minutes into there and we got negative 3. They're definitely solutions. So we have to test whether theta is 180 degrees is a solution. So we just go 5 times the cos of 180 degrees minus 12 times the sine of 180 degrees. Let's work out what that is. How do you do that? You draw the cos curve and the sine curve. What's cos of 180 and sine of 180? It's where the dots are. So that's 5 times negative 1 minus 12 times 0. What's that equal? Negative 5. It does not equal negative 3, so it's not a solution. So if the answer to that was negative 3, it means theta is 180 is a solution. So therefore, theta equals 180 is not a solution. Okay. Another question, okay? So let's solve this one. Sine theta plus cos theta equals negative 1. Do we recognize it as a type that would use T formula? Yes, because it's not equal 0. If it was equal 0, take your cos to the other side, divide by cos and, you know, make it into tan. But this cannot be made into tan. So we're going to use using T formula. So we've got sine theta, isn't that 2t over 1 plus t squared? And cos theta is 1 minus t squared over 1 plus t squared. Now that we put that equal to negative 1. Remember that t equals tan theta on 2. So denominators are the same. That's good. 2t plus 1 minus t squared over 1 plus t squared equals negative 1. Are we? So what I'm doing, my denominators are the same. I've combined my numerators. All right. Now I'm going to cross multiply. 2t plus 1 minus t squared equals negative 1 times 1 plus t squared. So 2t plus 1 minus t squared equals negative 1 minus t squared. Now I can already see those t squareds are the same on both sides, same sign, they're going to cancel. And that is how you know 180 is going to be a solution. when the t-squareds cancel and you don't end up with a quadratic, you can end up with a linear equation. 180 is going to be the other solution. All right? So what have I got? 2t plus 1 minus t squared plus 1 plus t squared is 0. The t squareds cancel, and I get 2t plus 2 is 0. You good? In other words, 2t is negative 2, t is negative 1. Oh, this one's not a hard one. This one's a nice, easy one. Because what does t equal? Tan theta on 2 is negative 1. All right, so we've only got the one solution here to work out. But even if your t-squareds don't cancel, you should check x theta is 180 for every equation, because they often dedicate a mark to it. All right, so what's this telling me? So 0, I have to solve for 0 to 360, but I'm just doing theta on 2, so I only need to do quadrants 1 and 2 if needed. So tan theta on 2 is negative 1. So what does the negative tell me? Quadrant 1 or 2? So acute angle theta on 2. So ignoring the negative now, tan of what is 1? But that's not quadrant 2. How do I do quadrant 2? So don't forget to do this step. Theta on 2 is 180 minus 45. So theta on 2 is 135. We okay? In other words, theta is 135 times 2. It's 270. Now, if we look back here, we notice that our t-squareds cancelled. And this is your warning bells that theta is 180 is going to be a solution. All right? So we know, because we got reduced down to a linear equation, which means only one answer, one solution. So let's check now. So sine theta plus cos theta is negative 1. All right. We're going to check. We know that 270 will work. I'll just have a quick look. Look, just have a look for sine and cos of 270. I've just marked where they are. We know that 270 is going to work, but I'll just check it. Look, sine of 270 plus cos of 270, I'm going to show you what it is. It's negative 1 plus 0, that equals negative 1. We knew that was going to work because that's what we got for our working. But if you ever want to check your answer, you can. You now must check if theta is 180 is a solution. So let's try. Sine of 180 plus cos of 180. We need to see if it's negative 1. What's sine of 180? That's the sine curve. That's the cos. What's sine of 180? There it is. And cos of 180 is negative 1. 0 plus negative 1. 0 minus 1 is negative 1. So sine theta plus cos theta does equal negative 1 if theta is 180. So therefore theta is 180 is a solution. So you've got two solutions, 180 and 270. Okay, so this is an example where checking for 180 works. All right.